Salam and welcome everyone. Today we're going to be working on the question on the screen that says at 100 degrees Celsius, temperature 100 degrees, pressure 16.0 kilopascal, the mass density of phosphorus vapor, which is gas, is 0.6388 kilograms per meter cube. What is the molecular formula of phosphorus under these conditions? So we're trying to find the molecular formula of phosphorus atom or phosphorus vapor under these conditions. So that is basically what we're supposed to do. Since we're hearing the word vapor and we're seeing like the temperature and we're seeing the pressure, this is a perfect gas question. This is a type of format that they take. It's just that this is a more complicated one where you have to use your intelligence to solve it. So I require everyone to be very focused as I do this problem. So you've got temperature. Since we're going to be dealing with perfect gas, we can go from degrees Celsius to Kelvin. So we can say 100 degrees plus 273.15, and we end up having the temperature to be 373.15 kelvins. We have the pressure, and then we have the basically the mass density, which is the same thing as just the density, which is just 0.6388 kilogram per meter cubed. What is the molecular formula of phosphorus under these conditions? Well, we first of all write out our perfect gas equation. We have PV equals nRT. We see that we've got temperature, we see that we've got pressure, we see that we have the gas constant because the gas constant is a constant. So no matter what, you're going to have in the question. And you can either use one of the two gas constants, which is 0.08206, or you can use 8.3145, whichever one works for you. And just keep in mind that the units of both gas constants are usually very different. So whatever is easiest for you and whatever the unit entails that you use is what you're going to use. I'm not going to write the units of both here just because there are multiple units that both forms can take. So you have all of this information, but you don't have the volume and you don't have the number of moles. But what you do have is the density. And we know that density equals mass over volume, right? And we also know that number of moles equals mass over molar mass. And we have volume where we can substitute um, the information in terms of density and mass from this first information I'm boxing right here. And then we have the number of moles over which we can substitute mass over molar mass for, because we're actually even solving for the molecular formula. So we're going to do that. We see that density equals mass over volume. To write density and mass in terms of volume, we have divided by density. This is how you do it. So we have pressure, right, times volume in terms of mass and density. So that will be mass divided by density, okay, equals number of moles equals mass over molar mass. So mass divided by molar mass. So you have this here, and then you have R, and then you have T. So you go on to cancel out the mass to make our work easier. And what you end up with would be pressure divided by density equals R T divided by molar mass. So what this is telling you is that this is the new equation that is formed. But before we can use this equation, we have to make sure that everything is checking out, right? We've got pressure. We actually have a parameter for pressure, which is what we've given us 16.0 kilopascal. We have the density. We have the gas constant because it's a constant. We have the temperature. We actually do not have the molar mass. So in this case, we have five parameters that I've listed: pressure, gas constant, temperature, molecular mass, as well as density. But we have one unknown, which is the perfect way we like our questions whenever you're solving something. So to get this equation now in terms of M, we end up with RTD, so gas constant times temperature times density divided by pressure. And then we can input our information to this formula. Now, before we go on to solve anything further, I want to first of all show you guys that this density, we have it in the units of kilograms and meter cube. In chemistry, we tend to use our mass in terms of grams instead of kilograms, right? So we have to go take this 0.388 kilogram per meter cube, and we have to put it in a unit that is easy for us to use to solve this question. Well, in chemistry, we like to do grams rather than kilograms. And again, we just dealt with the question number of moles, and we have the molecular mass. Molecular mass is usually in grams per mole, not kilograms per mole. So we really have to go from kilogram here to gram. So that is that. Now we have meter cube. In chemistry, you can leave your volume in meter cube, but the best one is for you to leave it in dm cubed or in liters, because a lot of things are in this form. Not that you can't leave it in meter cube, but it's just easier and it's more common to have your stuff in either dm cube or liter. So we're going to go and make this liter. So we're trying to go from kilogram per meter cube to gram per dm cubed, or you can say gram per liter, because dm cubed is the same thing as liter. The only difference is dm cubed is used in the UK, liters is used in the US. That's literally like the major difference. Like when you're dealing with students in the British curriculum, they're going to be using more of dm cubed. If you're dealing with students in the American curriculum, you're going to be dealing with liters. So that is all. That is literally all. So yeah, that's all. So now we're going to go from kilogram to meter cube to gram per liter. So we're going to use dimensional analysis. So we're going to have 0.6388 kilogram per meter cubed times, okay, kilogram at the bottom and gram at the top. So we know that 1000 kilogram gives us, sorry, 1000 gram gives us 1 kilogram. So we can easily cancel out the kilogram and we have gram. Now we have to go from now we have to go from meter cube to dm cubed. So we have the meter cubed up top and we have the dm cubed at the bottom. We have to know this, that 1 meter, going back to basic math and unit conversion, is the same thing as 10 decimeter. Okay. So 1 meter cubed is going to be the same thing as 1 times 1 times 1, which is 1. Then meter times meter times meter, which is just meter cubed. So you have 1 meter cubed. While 10 decimeter cubed is the same thing as saying 10 times 10 times 10, which is 1000, and dm cube times dm cube times dm cube, which is dm times dm times dm, which is dm cubed. So you can see now that 1 meter cubed is the same thing as 1000 decimeter cubed. That's how you do it. So now we can now put that information here. So we are going to have 1000 decimeter cubed for 1 meter cubed. So that's how you do it. So now let's go on to finish solving it. By the way, we are just trying to get in the right unit. We're not even actually started solving what we're supposed to solve for. So we have meter cube cancel meter cube. And we actually have 1000 at the numerator and 1000 at the denominator. So we cancel out this as well. So we end up with 0.6388 gram per dm cubed or gram per liter. So you end up with 0.6388 gram per liter. And that is what we're going to input when we're solving this question. So now we're going to ignore all the stuff I just did at the bottom and we are going to go back to the top to solve the actual problem that we're given. So what do you call it? So uh R here is going to be um sorry, I'm gonna just rewrite this. So we have RTD divided by P. So we're going to use the gas constant 8.3145 because it is the units match properly in this question. So kPa times liter divided by mole Kelvin times temperature 373.15 Kelvin times density 0.6388 gram per liter. All of that information divided by pressure, which is 0.16.0 kilopascal. So we're going to cancel out kilopascal, kilopascal, cancel out Kelvin, Kelvin, cancel out liters, liters. So you put all of this information in your calculator. But before we put it, let me just rewrite it down for any student that may be confused because this is a lot of information. So 8.3145 times 373.15 times 0.6388. And then you have gram per mole, okay, because that's what we're trying to solve for, molar mass or yeah, molecular mass. And then you have divided by 16. So input this information, the numeric values into your calculator, and you're going to end up getting 123.8695 gram per mole. Okay. Now we've been successfully able to get the molecular formula. But what this question asks us to solve is for the molecular. Sorry, we've successfully been able to get the molecular mass. What this question asks us to solve for is the molecular formula of phosphorus. And phosphorus is an atom. Now we're dealing with phosphorus vapor, and they want us to find the molecular formula for phosphorus vapor. Well, now we have to understand that we have the molecular mass, which means that this phosphorus is actually a molecule, meaning it's not just one atom of phosphorus that is available. It could be two, it could be three, it could be 50, it could be more because we're dealing with the molecular formula. So there has to be at least two atoms of phosphorus. So therefore, since we've solved for the molecular mass, we now have to go on to our periodic table, find the atomic mass. So here we have molecular mass. Let's call it mm now. And you have atomic mass. So go find in your periodic table the atomic mass of phosphorus. So looking at the periodic table, you will see that the atomic mass is 30.974 gram per mole. Are you seeing what's going on here? So now what you're going to do to find the molecular formula MF is that you're going to divide the molecular mass by the atomic mass to find the number of phosphorus atom in the phosphorus vapor molecule. So you end up with 123. Let me take this up a little bit. 0.8695 gram per mole divided by 30.974 gram per mole. We cancel out the gram per mole because we're not finding unit of anything. We're trying to find how many of it exist. So you put this information in the calculator. So the molecular formula becomes 123.8695 divided by 30.974. And we're going to get 3.999 as the unit. But because we have to approximate, because we cannot have it, we need a unit number. And to approximate this, we have the molecular formula to be 4. So what you're trying to ask you now is, what is the molecular formula of phosphorus vapor under the conditions given? So that means we're going to have 4 atoms of phosphorus for this question. And that is the same thing as having P4. So molecular formula is P4. So this is a molecular formula value. So the molecular formula for this question is P4. So that is how you solve this question. You can see how complicated it looks, but you have to use your intelligence to be able to solve this. So hopefully this has been very easy for you. So if you have any questions, put it in the comment section. If you'd like me to be your personal tutor for chemistry, math, and other STEM related subjects, make sure you email me at shahabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.